In today's video, we're going to start by talking about different number systems. Okay, so here's the integers. The integers are whole numbers, positive and negative. The rational numbers can be described two different ways. We can describe them simply as fractions, that is, anything that can be written as a over b, where a and b are both integers, and of course b can't be 0. Or we can describe them equivalently as decimal numbers that terminate or repeat. So any fraction can be written as a decimal number that either terminates, or if it doesn't terminate, it repeats. Now, irrationals, that are basically whatever's left, so we're left with decimals that do not terminate and do not repeat. And here are some examples of irrational numbers. A square root, where the radicand is not a perfect square. Anything involving pi. And here we have an example of a decimal number that does not terminate, as we see by these 3 dots, and does not repeat. See the extra 0 in each set doesn't form a repeating pattern. In number 1, we're asked to circle the numbers that are not rational. Okay, not rational, that's the same thing as irrational. So the first number is -7. That's an integer. All integers are rational numbers. They can easily be written as fractions. Just stick a 1 in the denominator. All right, so this is rational. All right, the second one is a terminating decimal. That's also rational. So we won't circle that. Okay, the third one, 2 pi. Any expression involving pi is irrational, so let's circle that. All right, and in the next one, we have a number that is does not terminate, and it follows a pattern, but the pattern is not a repeating pattern, so we will circle this. This one's irrational. All right, -3/7 is a fraction, so don't circle that. That's definitely rational. Here, the square root of 36, well, that's equal to 6. 36 is a perfect square, so this is rational. The square root of 3 is irrational. 3 is not a perfect square, so that's irrational. And finally, the last number doesn't terminate, but it does follow this repeating pattern. You see how the 3, 5 repeats. So it follows a repeating pattern. So this one is rational, so don't circle this. Number 2 asks which are rational but not integer. All right, -5 is integer, so don't circle that. 10/2, well, that's actually also integer. 10/2 is equal to 5, so don't circle that. Square root of 3 is irrational. It's not rational, so we won't circle that. Square root of 25, that's an integer, so don't circle it. Okay, 3.5, that's a mixed number, but we can write that as a fraction, so that is rational, and it's not an integer. Okay, here also we have the last one, number is definitely not an integer because of the decimal portion, and it doesn't terminate, but it follows this repeating pattern. You see that repeating pattern, so that is rational. So we'll circle that. In 3, we want the additive inverse of -2/5. The additive inverse is just the same number with the opposite sign. Okay, so that would be 2/5. In number 4, we want the multiplicative inverse. The multiplicative inverse is the reciprocal. Okay. Okay, so we want to take the reciprocal of 4 2/3, So in order to do that, we'll write this as a fraction. Just first change it to a mixed number. Okay, we do that by multiplying the denominator times the whole. 3 times 4 is 12, and adding the numerator. 12 plus 2 is 14. So this is equal to 14 over 3. All right, so the multiplicative inverse of 14 over 3 is 3 over 14. In number 5, we want to approximate 3 over 7 to 3 decimal places. All right, so remember we said that fractions are the same as decimals that terminate or repeat. All right, so we could change any fraction to a decimal that terminates or repeats, and we can go the other way as well. We can change any decimal number that terminates or repeats to a fraction. All right, here are two examples. First, fraction to decimal, 1/4. That the fraction 1/4 is equal to the decimal 0.25. And going the other way, the decimal number 0.123 is equal to 123 over 1,000. All right, now 3 over 7 is an example of a decimal number that repeats, but it repeats after many digits. So we're just going to find 3 decimal places. Now, you see this word approximate. The word approximate means that we should round. So that means we should find 4 decimal places and round. So that's what we'll do. We'll find the first 4 decimal places and round to 3. If the wording of the question were different, if it said find the first 3 decimal places, then we would just do that. We wouldn't find 4 and round. We would just find the first 3. So because of the word approximate, we're going to round. So let's do that. So we have 3 over 7. To change it to a decimal, we just divide denominator into numerator. So we're dividing 7 into 3. All right, so let's do that. Just a long division. Now we need to find a total of 4 decimal places. So I'm going to add 4 zeros onto the end after the decimal point. And bring the decimal point to the top and start the division. 7 into 30 4 times. Okay, just bring down the 0. 2 times. Okay, here we have 8 times. And finally, 5 times. Okay, so here are the first 4 decimal places, and we're going to round to 3. Since the this is 4 decimal places, and we're going to round to 3. Okay, so this last decimal place, the 4th decimal place, is 5. Since if the last decimal place is 5 or greater, then we do our rounding. So we're going to add 1 to the place next to it. So this is approximately equal to 0.429. Number 6 has to do with using order of operations. So let's remember the order of operations. So we do operations in parentheses first, and then we do any exponents, and then multiplication and division left to right, and addition and subtraction left to right. All right, so let's do number 6. We're going to simplify this expression. I'm just going to rewrite it over here. So we'll start with the innermost parentheses, 3 minus 6. That's negative 3. I'm going to just write it above. And then let's do the brackets over here. Let me just cross this out. We'll do the brackets over here. So we're going to now do the operation 7, subtract minus 3. 7 minus minus 3, that turns into 7 plus 3. Okay, 7 plus 3, that's 10. Okay, and I just rewrite. Okay, so now we have a multiplication here, 4 times 10, and the multiplication here, we'll do left to right. First we'll do 4 times 10, 40. Okay, now we can do 5 times 4 is 20. And now let's just add these up. Okay, so here we have 60 and 2 is 62. Here we have another order of operations example. Okay, let me just copy this over. 2 times 3 minus 2 times 3 times 5 minus 3 plus 7. Okay, so I'll start in the parentheses, and we'll start by doing the multiplication. All right, so that's 15. And let's continue by doing the operations in parentheses. So 15 subtract 3, that's 12, plus 7, that's 19. Okay, so now we have a multiplication here, and this is another multiplication. Let's start by doing this multiplication. So we have 6 minus 2 times 19. Now, we can't subtract 6 minus 2. That's a common error, because here we have a multiplication that we have to do first. All right, so that's 6 subtract 38. All right, and so finally that's negative 32. In number 8 we have the expression 2 minus 4 squared. So we do the exponentiation first. So that's 2 subtract 16, which is equal to negative 14. Let's look at another example related to this one. Instead of 2 subtract 4 squared, let's say we had 0 subtract 4 squared. Okay, so we're doing it the same way, exponent first. That would be 0 minus 16. Now this is exactly the same. We didn't have to write the 0 here. This is exactly the same as negative 4 squared. So from this example, we see that minus 4 squared is equal to minus 16. In other words, do the 4 squared first, and then just keep that negative symbol in front. So that's minus 16. If we wanted to square negative 4, all right, that would be another example. To square negative 4, we would write it like this. We would write the negative 4 in parentheses, and then that would be equal to positive 16. We saw in the previous example that, let me just put it in parentheses, this is from the previous example, we saw that minus 4 squared is equal to minus 16. So we learned in this example that we first exponentiate, and then we put the negative sign in front. So we're going to do the same here. Minus 3 to the 4th, we'll first calculate 3 to the 4th and keep the negative sign in front. 3 to the 4th is equal to 81. So this is negative 81.